Alrighty. So on this first one, how many sides does this have? 8 sides. What do we call that? Okay, this is an octagon. Now what I want you to do is to find the total number of degrees in this octagon. So how do we find the total number of degrees in a figure? N minus 2 times 180, that little formula we talked about yesterday. What does the N mean here? It's how many sides it has, right? So this has 8 sides, so to find the total, I'm going to do 8 minus 2 times 180 degrees. All right, so 8 minus 2 times 180. Now, let me remind you something on here. Make sure that you put that 8 minus 2 in parentheses, because if you don't, you get negative 352, which makes no sense. 8 minus 2 times 180 gives you 1,080. Why does it matter in your calculator? What's your calculator doing to give you negative 352? Okay, good. It's following order of operations. So what's it doing first? It's doing the 2 times 180 first, and then it's doing 8 minus that, which is 8 minus 360. Okay? So that's the reason you put the 8 minus 2 in parentheses, is to make it follow, well, it's always following the order of operations. It's to tell it what operation to do first. We wanted to do 8 minus 6 first. Or 8 minus 2, I'm sorry. So what does the 8 minus 2 tell me? From yesterday, what did that tell me about that? It's how many triangles we can draw inside of that figure, right? So 8 minus 2 times 180 is 1,080. Okay, so that's the total number of degrees. And that's what I asked you to do, but I want to take it a step further. Okay, now assuming that this is a regular octagon, that means all the sides are the same length, all the angles are the same. I want to find the measurement of one of these angles. How would I do that?
Divided by 8.
Yeah, take the total, divided by how many angles there are. There's 8 angles, so if I do 1080 divided by 8, what does that give me?
135.
It gives me 135 degrees. So what I want you to do is use your protractor, and I want you to measure one of those angles. Bam. All right. So how big is that angle? Okay, so something in the drawing got off just a little bit, so I don't know exactly what happened there. But you can see it's really close to 135. It's 134, really, on this angle. So it's got to be made up somewhere else. But you can see it's right between 130, 140, off by just a little bit. It's because the drawing's not exactly right. But so you can see that works right there. Okay, so that's the stuff that we worked with yesterday. I was talking about these interior angles. And we're still going to be dealing with those today. But what I want to focus on a little bit today, right now, is these exterior angles. So obviously to have an exterior angle with a polygon, you've got to extend these sides out like this, okay? Making these exterior angles. So what I want to do is I want to measure these 5 angles. All right? So go ahead and use your protractor and measure angle 1 real quick. Remember, when you measure it, you get this line on the paper matched up to this line on the protractor, and that vertex to this vertex. So line to line and vertex to vertex. Okay, actually let me do it like this. Let's see it better. What is it? Okay, let me do it like this. Okay, let me remind you on this. Now, angle 1, is it more or less than a 90 degree?
Less.
It's less. So that's why I know for sure it's not the 110 or 120. It can't be that. That's way too big. So I know it's the smaller set of numbers. It's somewhere between 60 and 70. And you can see as you count up 61, 62, 63, that angle is 64 degrees. That's right, 64. Okay, let's measure angle 2. So how big is angle 2?
70 degrees.
Okay, that's as 70 as 70 gets. Okay, I mean, you can't be more 70 than that. That is 70 degrees. All right, angle 3. Is what?
56.
A little bit more than 55. Looks like it's about 56 degrees or so. Okay, we're gonna go with 56. All right, angle 4. Is what? Just a little bit more than 80. Looks like about 81. And now angle 5. Okay, yeah, let me get it lined up better here. It's about 89. All right. Now, with those 5 angles, there's not any correlation really between them individually, but there is something true of these angles collectively. So what I want you to do is in your calculator, add those 5 numbers up. Don't say anything, just plug them in. I want you to add up all 5 of those angles real quick. Don't say anything, just add them up in your calculator. Alright. You're adding all 5 of these angles up. 89, 64, 70, 56, and 81. Add them up. And what do you get? 360. Okay? That's not by coincidence. So, now here's the thing. The exterior angles are always going to add up to 360. It doesn't matter what shape it is. Okay? That's different from yesterday. Yesterday with the interior angles, the more sides you have, the more total number of degrees you get. Okay? With exterior angles, it does not matter how many sides, it'll always be 360. So, like on this one, what type of shape is this right here? This is a pentagon. Okay? And we saw that added up to 360. Now, this one right here, what type of shape is this? Okay. This is a hexagon. Okay. Now, this one, you don't have to measure it on your paper. Just follow along. Let's just get these numbers together real quick so you can see this. All right. So, this angle right here, how big is that? It's right at 74, it looks like. Zoom in. So, about 74 degrees for this one. Okay, on this one, how big is this one? It's about 47 degrees. Okay, on this one, how big is this one? Is 77. Okay, on this one, sorry, about 46 degrees. Okay, then this one, about 50, somewhere between 51 and 52. We'll say 51. And then this last one right here, about 65 degrees, somewhere around there. Okay? All right, so go ahead and add those 6 numbers up real quick. Add those 6 numbers up. And what do you get?
360.
You get 360, okay? So what ends up happening is as the number of sides increase, those angles just shrink more and more. So that's why it just stays as 360, okay? The more sides you get, the smaller they get, and it's just always going to be like that. The exterior always add up to 360. So you can see that with 2 examples there. We could do that over and over again and see that's the way it's always just going to work, okay? Now again, it's different than interior. Interior depends on how many sides for the total. Exterior is always 360. All right, so let's go ahead and flip it over. All right, and I'm going to skip down here to this example 7. Okay, how many sides does this shape have?
7.
Okay, there's 1,
Is this
2,
septagon?
3, 4, 5, 6, 7. So there's 7. So what do we call that? Okay, sept is a prefix used for the number 7, so that's good, but we actually call this something a little bit different. It's very similar to septagon, but it's a
Septagon.
heptagon.
Interesting.
Okay? Heptagon. Heptagon is what we call a 7-sided shape. All right? Which actually really doesn't matter for what we're about to do right here, because what we're dealing with is these exterior angles. So this 5x is talking about this angle. This 4x minus 6 is talking about this one. So what do those 7 angles add up to? 360. Okay? It doesn't matter. It's 7 sides, it's going to have 360. It does 100 sides, those exterior are going to add up to 360. Now on this one, instead of me writing all that down, let's just do this in our head real quick. Okay? Add all these up. So I'm going to start up here with this 5x. So 5 plus 4 is what? Is 9 plus 5, 14 plus 4, 18 plus 6, 24 plus 2, and 26 plus 5 is 31. Okay, so we have 31x. Now let's add up just the constants, just the numbers. Oops. So we've got, negative 6 minus 5 is what? Negative 11 plus 3. Negative 8. Negative 8. And then negative 8 minus 12. Negative 20 plus 3. And then negative 17 plus 5 is negative 12. Okay. So instead of writing all that down, we just added all that up in our heads. But when we add all that up, what is it going to equal? 360. Okay, since it's exterior angles, they always add up to 360. And then from here, it's just simple algebra to solve for x. So we're going to add 12 to both sides. So this zeroes out. We get 31x equals 372. Okay, let's get this down. Then divide by 31. And x equals 12. Okay? All right. So, I mean, really, that's pretty simple. So let's do it again on this one real quick. All right. So let's add these up in our head again. 4x and 6x. 10 plus 5. 15 plus 5. 20 plus 2. And 22 plus 3,
25.
so 25x. So we have 25x. Now for just the numbers, so 5 plus 4, 9 plus 2, 11 plus 3, and 14 minus 4 is 10. Okay, so all those together equals 360. Subtract 10. That zeroes out. 25x equals 350.
50.
14.
So x equals 14. All right, on this example 9, it says find the measure of each exterior and each interior. So we're going to have two different things we're doing here. So we're going to find each exterior and we're going to find each interior of a regular decagon. Okay, so decagon has how many sides? 10 sides. And what does regular mean? All the sides are the same length, all the angles are the same measurements, okay? So we need to know that to do what we're about to do right here. So each exterior, this is like what we just talked about today, and each interior is what we talked about yesterday. So let's go ahead and do this first, the each interior. Okay, before I find the measurement of each interior, I've got to find the total of the interior. So how am I going to find the total of the interior angles of a decagon? Okay, so I'm going to do the 10 minus 2 times 180. That's going to give me my total. What does that give you?
1440.
So that gives us 1,440 total degrees for those interior angles. But I want to know how big each one is of this regular decagon. So what am I going to do?
Divide by 10.
Good. I'm going to take the total of 1440, divide that by those 10 angles to see how big one of them is. And what is it? Okay. So 144 degrees is the measurement of each interior angle. Now, like what we talked about today, is I want to find the measurement of each exterior, and this is a regular decagon. So everything's the same here. All the sides are the same. So how am I going to find the measurement of each exterior? Good. There's a total of 360 degrees. There's 10 angles, 10 exterior angles. They're all the same. So what's that going to give me?
36.
So 36 degrees is going to be the measurement of each exterior angle.